Hello everyone, welcome back. In this video we'll learn how to create LED teasing effect with Arduino. So let's get started. In our previous demonstration, we have used two LEDs for alternate blinking. Now we'll modify that code for LED teasing effect. So let's build up the circuit. First we'll take 5 LED. And there will be up to down and down to up sequence. Lighting of disability. So let's see how we can do the circuit build-up. So we have taken 5 LEDs, and we need to connect them one by one. Now connect all the catalogs and make them common. With this resistance. Our circuit is complete. We can increase the resistance value to some. Another value like 560 on. Now let's come to the programming part. What chants we should bring in? Into the code that we previously built. So first of all, in the void setup section, we need to define that we have used 2 to 6 number pin total 5 pin as output. We can do so by copying this code and pasting it for 5 times, and edit that code for full 5 and 6. So this is how you can define all the 5 pins as output. We can make it shorter by using follow. I will show that later. Now come to the programming part. We want to lead and light one by one. That means at the first step, this red lady should turn on. In the second step, red and blue should turn on. In the third step, this 3 lights should turn on. And the sequence should go in this manner. At the final state, all the 5 already should turn on. Let's do that. So at the first state, only the LED 2. The disconnected to P 2 will turn on. After that, let me copy this block of code and I will paste it. And the second time, 3P number connected LED should turn on. Then the LED connected to 4 should turn on. In this manner we can turn on all the LED by sequence, with a delay of 200 milliseconds. So let's run this program and see what effects it bring. So you've seen it was quick. Let me change the value of delay. Now it will pause for half again. You can see all the LED was going down to up. Now let's say you want to do the opposite in manner. That means you want to turn this off after all the 5 LEDs are turned on. It should make us effect like going up to down. For that reason, we can change the code for turning consequence. And remember to make any comments in your code. You can use this // and it will make a comment for you. Good comments are good for making readable codes. So you should have a practice of using comments when you are programming. Now let's say I will turn the LED connected to 6 number pin below. And the dealer should be 500. Let me copy this block of code and repeat it. So after 6, the 5 should go off, then 4, then 3. Then finally 2 should go off. So after coming here, it will go again at the start of the wide look. And again their turning on sequence will go on. So this the fast block of the code. It's turning on sequence. And the second block of the good is turning consequence. So let us see what is the final effect of our good. What a nice effect. I hope you got the idea how to make a LED chasing. I'll share this piece of code with you and see how we can share code from OK. First of all, you need to save your code, give it a name LED Jessing. With the free version, you can only make your code as public and save it. You cannot make it private. Now let's share Discord. You only need this link to access Discord. I will add Discord to the description so that you can take a quick look at the code and the circuit. So that's it for this video. I'll see you in the next video. Hello everyone, welcome back. In this video, we will learn how we can modify the previous LED chasing program with a shorter version of code. So let's get started. Before going into the program, let me introduce the concept of for loop. And while for loop is a programming component that can make statements and go irritably executed, like here when we use for loop, we first need to write for. Then within the bracket, first of all, we need to initialize a variable like intisal. I is called to 1. It could be any variable like intisal, ABC, or anything you want. Then we need to put a condition for which the loop will execute. So let's say I is equal to 1. 1 is less than 5, so for this tongue, it will execute the loop. Then after execution, it will come again into this spot, and it will increment the value of I by 1. After incrementing, it will again test the logic. If the logic is true through fast exhibition, I will be 1, 1. That is, I will be 22 and 2 is less than 5, and it will again enter the loop statement. In this manner, it will go on until I becomes 5. So 5 is less than 5. It's not true statement or true condition. For that reason, it will exit the follow-up and come to the next statement. So in this manner, follow-up works. All the conditions, the initialization and increments, these are also present in while loop structure. See here faster following it. To initialize stuff by loop variable, then we need to put a condition in between the fast brackets, and at the end of the while loop, we need to introduce the increment. Both works the same way, so let's see how we can use for loop to make our code more efficient and shorter. We'll start from here. In the previous program, we have used pin mode command 5 times for defining the pins as output. We can make it short by using for loop. Notice here the pin mode becomes from 2 and go up to 6. So remember, this will make a for loop to make this code shorter. For into the I will start from 2. Because our standing bell is 2, and I will go for equal or less than 6. Because the last value is 6, and I will be decremented by 1 each time. Then we need to give the command that we want to do repeatedly within the loop high output. So now we can erase this code, and all the functionalities of the previous code will be executed with this element of code. I hope you got the idea how to use for loop. In the same manner we can do for fanning on sequence. So let me introduce a follow-up here. So for the fast value is 2 and last value is 6. As previous in desert I equal to 2. I lists are equal 6i++. And what do you want to do repeatedly? We want to make digital write to pin number high. And make it high. And then we want to make a delay. Delay should be for 500 milliseconds. And it will keep doing this until I reaches the value of 6. So within this 3 line of code, we can replace this 10 line of code. In the same manner we can replace this 10 line up code with another follow. But remember in this case, the sequence of values start from 6 to 2. So it will go downwards, remember that. So let start I with 6, and it will be greater or equal to 2. And I will be decremented. And each time the loop it duets, it will make the I value, that is the pin number, low. So you can see with this follow structure, we can reduce all those scores within this simple lineup chords. So let's see if the functionality is same as previous. So you can see the code was the same. But this time our code is more modified, more efficient and more shorter than the previous ones. So see you in the next video. We'll do some more fun experiment with LEDs. Thank you. Hello everyone, welcome back. In this video, we'll learn how we can interface abilities without an O, so let's get started. There are two types of RGB. The first one is common cathode, and the second type is common anode. What does it mean? You can see the RGBs have 4 terminals and 1 terminals are, that is red, G for green and B for blue, and the another terminal. It's common terminal, so this common terminal. If the RGB is common cathode, that means this common terminal, we need to ground it. And we need to put power for this range. Green and blue. The alternate is true for this common anode. That means we need to provide positive supply at the common terminal for common anode and provide drowning for this road and B terminal. So this is the basic difference of common cathode, common anode. Now the voltage we provide, that is the value we provide for red, green and blue. It will combine themselves and make a color from RGB values. What I mean, let me show you from my website. So this is a website from Adobe. The link is colored Adobe.com /color will from this base. Let me explain what is the different values of RG and B can create. So let's say if you want to create red color, you need to put the maximum hello for our channel and put the other to terminal as 0. So it will create a red color. You can see that to 55 of red. And other novels of green and blue create red color. If you want to create green color, just put the value of green channel 2 to 55. And other to channel 0, it will create the green color. If you want to create blue color, just put the blue channel value to maximum and put the other to channel to 0 values. Now what will happen with if we mix different ratio of this channel? Let's say I have kept the red channel to 0 and put green and blue to some values close to 181 and 170, it will create a greenish color. Okay, so now if you increment the red, you see the color changes to another color. So this is how with different combination of red, green and blue we can create different colors. Okay. So let's see how we can use these formulas or use these values for creating any color in our RGB and agility. So let's come to agree here. Let me keep it aside from the take new part. Look for hard ability bringing in arguability. When you click on this arguability, you can go for both mode. Like you can make it a common anode or common cathode. Let's say I'm making it common cathode. That means I will have to supply ground to this common terminal. Now we need power supply and we need ground pin. Let's see if we go down. We have in the power section VCC. Also you can search here GND, that is the ground. So just for demonstration purpose, let's create a red color. That means one want to supply only the red terminal channel And I want to ground the common cattle terminal, OK. Now if we run, let's see the color generated from this RGB LED's rate. If we do the same from green channel, let's say connect to green, you can see the color would big fan. Now if we create blue color, if you want to create blue color, just connect it to blue and it will create blue. So this is a confirmation that we can use our ability to create different color. Now let's connect to this AG ability to how do you know and create some amazing color product to work with. How do we know and AG ability? We need to understand some concepts related to analog output. That is, we want to introduce some new functions of our, in this project. Let us see the syntax for analog write. And we'll come back again at the circuit. So this is a slide from previous lecture. From this slide we already learned the pin mode, digital write and delay. In this lecture, we'll learn the command related to an elaborate. So when we want to use Arduino PW and feature, we can use analog write command. PWN is actually used for creating analog output, which is equivalent to PW output. And PWM starts for password modulation. I'm skipping the technical parts. And just remember, using the PWM pins, we can create analog output. And we can use analog write for those pin, for the speed1 pins. So when we are using analog write, we need to use this syntax first of all, right? The analog write command. Then you need to assign the pin number. The pin number could be any pin that we learnt before. That should be included in the pump shoe. It should have a sinusoidal sign in front of them. And then we need to put a comma. And put any value from 0 to 55. So 0 will give 0 voltage and 55 is the maximum value. It will give 5 voltage at the output. So this is how we can use analog write command. And this is the same text for that. Now let's jump into the program and see how we can use this command of analog write to create different colors with agility. Alright, we have come again into key platform. Now we'll do the wiring first. And then we'll program the circuit for ability programming. As previous for each other LED. We used Restore in series, so for the reason we'll bring in our oyster. We'll put some fellow close to 20 home. You can rotate the LED. Let's make some space here. Okay, let me copy this. We'll use 3 eraser. So the red one comes here. The green one comes here and so. And the common terminal, as this is a common catatape RGB we have taken. So that's why the common terminal will go to ground. Let's connect the rate terminal to 9. The green terminal to 10 and the blue terminal to 11. So that's all for the higher connection. We have taken agility converted to common cathode, connected the common terminal to ground, and other rate terminal to mine. Green terminal to 10 and blue terminal to 11. So we'll do the programming accordingly. Let's write the program for configuration. Pin mode 9 is our output. So this 9, 10 and 11 is our output. That's all for configuration. Now let's put some color here. We want to use analog write. From here you can see analog write is in the list. The syntax log analog write. We need to put the 9 yellow first. And then we need to put some yellows. Like to 55 is a maximum yellow. Let us add some comments. So this is red. This is green. This is blue and the red penis 10, blue penis 11, okay. So now if we want to see red color only, we need to put this Dallas to 0. And if we run this program now, you can see the color generated from Arduino is red. In the similar manner, we can do the other combinations also. So let it once again go to RGB color of will for Adobe. Let's say why we want to create yellow color from RGB. So for that reason red and green would be to 55 and blue will be 0, so let's do that. We'll put to 55 for red and green. And we'll leave the blue as 0. So now if we run this code, you can see the resulting color from RGB is yellow. Let's try one on another color. If you put the red channel to 0, and green and blue to 55, it will give a color like this. Put this 0 and this 2 to 55. Now let's run again. You can see the color is this color. We are getting from RGB, so this is how we can generate different RGB colors. Using RGB LEDs, I'm giving you guys the opportunity to explore this website. Create any color you want, and use this code to drive that color. So that's all for this video. In upcoming video, we'll see some more exciting projects with Arduino. So thank you. Roystor and Potentiometer. These two components are one of the fundamental components of electrical and electronic circuits. So when building an electronic circuit, we may need fixed ray stencil like this. Register, and this fixed what is registered. This comes into various what is like water watt 1/4, watt half watt 1 watt to watt 5 watt and 10. What's so different? What is this required for? Different application with different imperative. But if you need something invariable in nature, then the option we have is potentiometer. So potentiometer is basically a variable. For instance, there are several types of potentiometer available in the market. Like this one, this is called Sobo potentiometer. We have slight potentiometer, dual gain potentiometer, creamer, then single turn potentiometer, dual slight potentiometer, and so on. So among all of this, the single down potentiometer will study this sort of device and how to interface this sort of potentiometer with Arduino. Will land that in this video. Before going ahead, let me tell you this ray stance. The primary function of the ray stance is to introduce ray stance into an electrical or electronic circuit, and the ray stance is measured in ohms. The rest of values are typically marked on the components using color codes on the UCL virus. So if it is self-fixed, what ray stance you can see up to watt. There is color coded, but have a fire to watt, that is 5 or 10 watt. The watt is and the ray stance value will be written on the body itself. And the potentiometer. This comes into several values like 1 kilo ohm, 10 kilo ohm, 100 kilo ohm, 500 kilo ohm, and 1 mega ohm. These are the most common values available in the market for potentiometer. Here we can see a basic configuration of potentiometer. Without our potentiometer, it has 3 pins. We can use the first pin as ground. Then we'll have to supply into the third pin and take the middle pin. That is the second pin always as variable input. So in this manner we can use this potentiometer. You can also swap the ground and power 5 will supply. Like you can give 5 will supply in the first terminal and give ground in the second terminal. Also this button show me do this does not have any polarity, so you can stop the ground and positive supplying. Now here you can see basic connection is shown in the figure. The potentiometer, the middle point, that is the analog output from this potentiometer, and variable resistance will be taken from this pin. So this pin we have taken and given into analog input rail. That is easy to do a 5-pin for our no and the other 2 pins. The fast pin has been given fibre supply, and the tart pin has been given round. So this way, we can connect any potentiometer with our Arduino and take an output from this sensor. Or we can save this potentiometer. So let's see how we can use this potentiometer with Arduino and change the output accordingly in different applications like LED dimmer or RGB, light generation, etc. We have come into Oki platform. In the Oki you can find potentiometer from here. You go down from the part list, and in the below portion, you will find something called Potentiometer. So this potentiometer we can use for variable resistance. And it will be an analog input for, I don't know, so here we have 3 pin. The first pin is ground, the second pin is the signal pin, analog input, and the third pin is for resistance. So let's connect them. Connected to 5V. Connect the stain to any of the ground. And the connect to a 0 now. We want to see what value we are getting from this sensor. And for that reason we'll introduce another concept, that is serial printing and serial monitoring. Serial monitor is a way of absorbing different parameters of sensors connected with the Arduino in real time at the software using USB cable. So we'll see what it is in next example. When you want to use a serial monitor, you need to address 2 things. The first thing is, you need to initialize a serial monitor. For that the command is serial.begin. And then within the bracket you need to specify the baud rate or the speed. The standard values of speed is this values for 890601. 90 to 100 or 380. For 100 it's set a initialization of serial of command. It should be given into the word set apart. So this will initiate the serial communication. And the second thing you need to do, when you want to paint something, you need to use a function that is serial.print or serial.println. There is difference between this to command. Serial.print, it will print the values side by side, whereas serial.println, it will pin the values at a new line. So that's the basic difference between serial.print and serial.println. So now we'll see how we can use serial communication for our Arduino with our potentiometer and observe the values of the potentiometer. If you want to know more on serial communication, you can refer to this website from Arduino. That is arduino.cc/reference/n. From here come to this communication section, and under this communication we have serial communication part here. Once you click it, you will find the details of serial communication. The functions available under serial communication. Different functions are available here. You can explore them. You can also see the given example, so that you can have an idea how to use this in program. Like here you can see it's a program for CL print. The fast thing is, while using void setup, you need to initialize the serial communication. Then in your wide loop portion, you can print anything like serial.print, serial.print, double apostrophe of any string, and so on. So /t, this is used for printing a tab. These are called escape sequence in the language of programming. /t will print a tab, a horizontal tab. Similarly, we can use /n for new line, /v for vertical depth, and so on. Before going into the program, let me introduce the function called analog read. So analog read is basically used for reading analog values from analog sensors or analog inputs like button show meter. The syntax for analog read, we need to write analog read first, and then in the bracket we need to give the pin number. That is easier to fib any of the pin that we'll use for analog reading. For other no is 0 to fib for other board. It would be different pins. Also, you can also stud the value that you have read from sensor into a variable. That variable data type could be integer, float, or any other format. So here's some common data type used in C programming. Integer data type. It does not contain any additional values. It contains integer values, whereas floating data type, it takes in integer as well as floating part. That means the decimal part. There are some other data type like character string, boolean, so if your sensor value has decimal input, then use float. If it is integer value, then use integer. Now let's talk about the programming part. In the word setup, we need to initialize the serial communication only. So let's initialize the serial communication. Serial.begin 9600 values about rate. Remember, analog input does not require to define. Using pin mode I ought to mean, you do not need to write something like this, AO input. So how do you know inherently knows that this AO2? A5, all of this all is going to be input. So you do not need to define them, whether these are input or output. So for analog input, you can ignore this line of defining using pin mode. For word setup, it is enough to use just serial. Begin for initializing the serial communication. Now in the wide loop part, we will read these values from the potentiometer. We will print that value in a serial monitor. So let's do this serial print. And we'll give a message first. That is the sensor value. Then we will print the read fellow from the sensor. That is analog read and Israel. So it will read the AO pin and instantly print the values after the sensor value execution line. And after that, we need to put a skip sequence for new line. Okay, so it will bring the code for next reading into the next line. If you are done with the programming, you can do the simulation from here. So you can see sensor value. And the value it's reading is 0, because our potentiometer is in 0 position. Let's change the value of the potentiometer. If we rotate this dial, it will increase the value. And remember, Arduino has a 10-bit resolution for analog grid. That means whatever value will write from this pin, it will be between 0 to 1023, and water 1023 comes from to the power 10. And the maximum value will be 1023. Again, if you decrease the sensor dial up to 0 position, the value would be 0. So in this way, we can read analog sensor and apply this sort of input for different application, like motor control or LED fading, or RGB color creation, and many applications which will require variable input for controlling. So that's all for this video. I hope you got the idea. How to interface potentiometer with Arduino. How to program for a potentiometer using elaborate. How to use serial monitor to observe the values. In the upcoming videos, maybe we'll show you how to use LCD screen or other display devices to show this fellow in an external device. Remember this sensor value. We are seeing this using serial communication at the computer screen, not in any external device. We are observing this value in a computer software screen. So that's all for this video. I will see you in the next video. Thank you.